The revolution in thinking about extinction in the 1980s is exciting to remember. Really, though, it's easily summarized in the distinction between background extinction and mass extinction. Mass extinction is a completely different phenomenon. Definitions vary, sometimes as low as 50% of the species on Earth, and as high as over 90%, which certainly qualifies. Going extinct in an extraordinarily brief period of geologic time, something like 5 to 10 million years, is an eye blink in terms of the existence of the planet Earth. And for so many of the Earth species to vanish in that eye blink is mind-boggling. If it weren't for the data supporting it, no one would believe it. It's now common knowledge, I think, that there have been at least 5 mass extinctions in the history of the Earth, and you can find scattered all through the internet and all through any number of biology books the famous graphs depicting the massive extinctions occurring at specific points. One of the most famous being between 70 and 65 million years ago, sometimes called the KT boundary, the end of the Cretaceous, the extinction of the dinosaurs, although that's a little imprecise. It's tremendous to remember. People reading the work of David Raup and running off to museum collections and tracking rates of extinction as best as they could. And it's exciting to remember the debates about whether the crater in the Caribbean off the coast of Mexico is actually a meteoric impact site. The crater was discovered in the late 70s, but then dovetailed with the new ideas on extinction during the 1980s, and by the 1990s, sediment studies were demonstrating, sure enough, there's an enormous change in the composition of the outer layer of the Earth, right there at the KT boundary, consistent with the impact of a meteor.